Hey everybody, thanks for joining me for another edition of things that are pretty simple to understand on your own. Today we're going to look at the concept of ions and how they form. So this review question here, write the numerical setup for calculating average atomic mass. So we're dealing with percentages of and masses of isotopes here. So this is where you could apply the MAD calculation of 75 times 43 and 25 times 44, add those two values together, and then divide by 100 to get your answer. You should see that the average that you calculate would be closer to 43 than it is to 44 because there is a greater percentage of isotopes of the mass of 43 than 44. All right, so far in the various activities we've done in class, the simulations, the charts that you filled out, you have seen that if you change the number of protons in an atom, it changes the element. It changes its identity. It changes the location on the periodic table because that's the atomic number. If you change the number of neutrons in the atom, that will change the mass and make it a different isotope. So the last particle for us to look at is changing the number of electrons. This is something that was in the one paper lab that you did where you were adding or subtracting electrons from oxygen or lithium. So we're just going to go over it a little formally here. We're going to make an ion. So when you see the word atom, automatically you have to think and assume correctly that it is neutral. The number of protons will equal the number of electrons. So the positive charges and the negative charges will cancel each other out to zero charge overall. If you have an imbalance in the number of protons and electrons, you will create something that has a charge, and if it has a charge, we call it an ion. Now, there are two ways to alter the charge. I could change the protons because protons have charges, or I could change the electrons because electrons have charges. When you turn an atom into an ion, you must be changing the number of electrons. You cannot change the number of protons because that will change the element that it is. I don't want to change its identity, I just want to change its charge. So it's got to be electron. When you look at the periodic table, you can kind of predict the charge of the ion that an element is likely to form by looking at its number of valence electrons. And again, the valence electron is the last number of the electron configuration. Typically, if an element has fewer than 4 valence electrons, it tends to lose them. And if it has more than 4 valence electrons, it tends to gain more. The goal usually is for the valence, PEL, to have 8 valence electrons. That concept, called the octet rule, is really just to help to stabilize the element. If you look at your periodic table and find the elements that do already have 8 valence electrons, you should see that they are typically in the same group. So look at your periodic table and identify the types of elements or the group number that would have 8 valence electrons. When you do that, you should see that those are the noble gases. And if you remember from 7th grade science, I don't think they cover it in living environment, the noble gases are unreactive. The reason why they are unreactive is because they are stable. The reason that they are stable is because they have a completed set of 8 valence electrons. So looking at this, you can tend to predict if they're going to gain or lose. You need to make sure you understand what happens to the charge of the atom when it becomes a particular ion. So if you have an atom that gains electrons, it's gaining negative charges, its charge becomes negative because it's gaining more negatives. We call that an anion. If you are losing 1 or more electrons, you are becoming positive because you're losing something that's negative. That is called a cation. So a kind of cheap way to remember this, the letter N in anion can help you remember it's negative. And then for the cation, the T kind of makes a plus sign to tell you it's positive. Or you could just remember the names like a grown-up. And this is a very cheesy joke. When you look at the symbol for an element, And if it's an ion, it will have the charge written next to it on the top right of the symbol. So we have a lot of information now that we've put together. You have the symbol of the element. If you have a number on the top left, that will be the mass number. If you have a number on the bottom left, it would be the atomic number. That could be omitted because you could just look it up. And then if it has a charge written next to it, that shows you that it's an ion. So for this particular ion, I can determine the number of protons, neutrons, and electrons that it has. This nitrogen ion, this nitrogen cation, because it's positive, has a total of 7 protons because that's the atomic number. It would have a total of 8 neutrons because that's subtracting the mass number minus the atomic number. Now, how many total electrons would this nitrogen have? First, you need to figure out, did it gain or lose? Since the charge is positive, that means that this particular nitrogen lost electrons. How many did it lose? It lost 3, and I know that because it has a charge of positive 3. So if it were neutral, how many electrons would it have? It would have 7 to offset the 7 positives. But since this has a positive 3 charge, that means it has 3 fewer electrons, so it has a total of 4 electrons surrounding it. You could also do an extension and do the electron configuration. So if you look up the electron configuration of nitrogen on your periodic table, it says 2-5. So 2 electrons in that first PEL, 5 electrons in the second PEL. Well, if I want to do the positive 3 ion of nitrogen, and I said I lost 3 electrons, you're losing it from the valence PEL because those are the ones that are most accessible. So its configuration is 2-2, has a total of 4 electrons, which we said. Now this makes it more stable. It doesn't have 8, but it does have a noble gas configuration here with the 2 valence electrons. You don't really have to worry about the stability thing right now. What I want to make sure you know how to do is how to calculate the number of electrons that an ion would have if you're given the charge of that ion. So that's a quick lesson on ions. We'll work on some practice in class, but it's an overview that if an atom gains 1 or more electrons, it becomes negative. If it loses 1 or more electrons, it becomes positive. Subscribe below.